Oracle, SQL Server, etc. There is no software size limit, and there is an unlimited number of users. Furthermore, ArcSDE Geodatabases can accommodate vector and raster data, but as I said earlier, raster data is better stored elsewhere outside of ArcSDE. Performance is just not where we need it to be when we use ArcSDE to store our raster data. Okay, so just recall that. So for the most part, then what we're saying, or what I'm saying, is that the geodatabases are a great solution for vector data, and there are better solutions for raster data storage. I'm going to go back up to that second bullet, that there's no software size limit. No software size limit for these geodatabases. Of course, a person could argue, well, then you're limited by the size of your hard drive. But that is not really true either, because with these databases, if you run out of hard drive space on one server, then a person can simply add either more hard drives or add another server and create a volume on that server that is then federated, connected as a federated table to your original server. In fact, the server doesn't even need to be in the same building. The server could be in another building, literally across the nation, across the planet. Then there is really no software size limitation. There's no size limitation to the size of an ArcSDE geodatabase. So we've talked about a lot of differences, but in reality, we should probably concentrate more on the many, many similarities. Because what I've seen is that a person can learn to use the geodatabase with the personal geodatabase, and then transition that same knowledge, apply that same knowledge to using the ArcSDE Professional geodatabase. There's very little retooling or rethinking or relearning that you have to do when you're using those different types of geodatabases. So how do we express our data in the geodatabase? First of all, when we're dealing with vector GIS data, we can express that data as either a standalone feature class or as a feature class within a feature data set. Let's go into this in a little bit more detail. Geospatial data are stored as feature classes. Non-spatial data are stored as what's called standalone tables. Vector data is handled by DB2's spatial extender, or the spatial data blade of Informix, or any of the spatial modules of these big databases such as Oracle and Microsoft SQL Server. So this is what I mean by the vector data or the spatial data being handled natively by the database. SDE is essentially a broker. SDE is essentially a concierge, person opening the door, the doorman, and allowing the data to pass through from ArcGIS into the database. That's about all that ArcSDE needs to do today. And as I've said earlier, geospatial data storage for rasters is not recommended, so I'm not going to go into any additional detail with that. Internal data storage within, let's say, IBM DB2's relational database, all data is stored within what's called table spaces. And we can refer to a table space by its configuration keyword. A configuration keyword points to a set of two table spaces inside of the database. One is called the attribute table space, and the other is the coords table space. The coords or coordinates table space, as you can guess, is where the X and Y Cartesian coordinate vector data is actually stored. And the attribute table space is where the attribution, the fields and records the description of those points, lines, and polygons, where those are stored. The way that we would use a configuration keyword is, let's say in an enterprise situation, let's say we here in this office are responsible for the maintenance, the stewardship of a roads data set for the state. So on our server, we have a table space created called roads. In another office of the same enterprise, they also have a server, and these two servers are both, let's say, both running IBM DB2, and in reality, part of the same ArcSDE as the end user is going to see it. But in that other office, those analysts in that office are responsible for the statewide surface water layer. And so they may have a configuration keyword set up and a table space set up on their server for surface water. And that's where the surface water feature classes are stored. Doing things in this way allows us as database managers and administrators to control where the data is actually going, which can then affect the, let's say, the efficiency, the performance during editing sessions. It also can control kind of the file management on your server or set of servers as well. So the configuration keyword is very useful once we start working in the ArcSDE arena of the geodatabase. If we're working with personal geodatabases, it makes no difference whatsoever. It just doesn't get big enough or can't get large enough to make a difference. So how do we load vector data into a geodatabase? Perhaps we have a shapefile, as indicated on this slide. We have a Idaho boundary, so the outline of the state of Idaho. We have a shapefile, and we decided we're going to convert this shapefile into a standalone feature class. What we do is we go into Arc Catalog, locate that shapefile that we want to convert. We find it, right-click on it, and indicate that we want to export it to a geodatabase single. That's a conversion of one shapefile into one feature class. We'd be allowed to select maybe 3, 4, 5 shapefiles, let's say, and export all of them at one time into the geodatabase. And they would go in as 3, 4, 5, whatever feature classes. I do not recommend this approach because there's specific things that we like to do during the import that improves the usability of that feature class once we get it inside of the geodatabase, that you can only do when you do the import singly, one at a time. Okay, so that's how we're going to learn how to do this thing. So we have our input features as Idaho bnd.shp shapefile. The output location, at this point what we would do is simply navigate and point to the geodatabase where we want it installed. And then we would identify the output feature class, give it a name. It still could be called Idaho BND, or it could be Idaho Outline, whatever you want. You do not have to use the same name. And of course, it's really important to understand that you're not really storing a shapefile inside the geodatabase. It was a shapefile, and it still will be. You're not modifying that original file itself, but you're converting it into a feature class. So there's no reason to have a SHP anywhere in that output feature class name. The next line down is an optional expression. Here we can filter that input data. Let's say that we are bringing in the city's shapefile for the state of Idaho, the city's shapefile for the entire United States. But what we want to have put into our geodatabase are only those cities with a population greater than 10,000. What we would do here is create an expression, essentially an SQL expression, that would instruct ArcGIS to remove, I should say actually just select those cities with a population greater than 10,000 and only import those into the geodatabase. All those cities with a population less than 10,000, and it could be represented as points or polygons, all of those features will not be imported. They will be removed from the import process. That expression is one of the tools that we can use only on the import singly routine. And even more importantly is this next one, which is the field map, and it is also optional. But it's very, very good to use it, and I encourage you to take a look at this thing as you're going through this process. The first one is Object ID. Now, a new Object ID is going to be created for you in the geodatabase. So if a field called Object ID already exists, I recommend removing it. And the way that you do that is to select that field and then click on the X delete button off to the right of that field map box. You're also going to want to take a look at or look for some other what we would call legacy fields as indicated by this red highlighting that you see. The shape ST, shape underscore SDE something. Those are fields that are left over from previous imports, exports. It looks like this individual shape file has been in a geodatabase before, then taken back out into a shape file. Now it's coming back in. You'll want to remove those things. The shape area, shape perimeter, any of those sort of things that you find, as well as some of this old Arc info coverage type of fields or attributes. Things to look for there are the from nodes, to nodes, left polys, right polys, length, area, perimeter, those sorts of fields. If you find those, the best thing to do with those is delete them in this field map, this optional field mapping step. In the ArcSDE type of geodatabases, you can click on the drop-down arrow for geodatabase settings. It's also considered optional. And it's here that you would specify the configuration keyword that you want to use. And this again will determine the table space where these feature class or where this feature class is going to be written inside of IBM DB2 or Oracle or whatever it is. And recall that you could have one table space on one server, a different table space on another server, and so on and so forth. So this really does quite a bit of file management, database type of management administration for you. Let's look at the spatial index grid. This is kind of an interesting topic. You don't really have to make too many changes ever, really. It's good to understand what it is and how it works. The spatial index grid is a uniform grid of square tiles, like a grid reference on a street map. So if you take a look at the yellow pages or a phone book, oftentimes the first couple of pages you'll see a map of the city, and there's a grid over the top of that city, ABC along the x-axis, 1, 2, 3 maybe along the y-axis. And if you're looking for a certain address, you can look up the street. I think probably everyone has done this. You look up the street in the street index, and it says that that street is in C2. So then you can page over to the map itself, find C, the column, and 2, the row. Look inside that block, and if you study it long enough and have a little bit of luck, you'll find the street that you were looking for. Well, the spatial index grid is very similar to it, and it functions as a normal index that would be used within a more traditional relational